Okay, shall we start? Question number 21. Yes, but another time slots means uh, as I asked you earlier, there are few students who unable to uh, come for Wednesday class. So if so, please let me know your available time slots. Then uh, I can arrange another class for those kind of students. And in another day, the same class in another day, and same class in another day. And therefore, first, please send me your available time slots. Then, if they are matched, I can continue another another class for those systems. And දහම් දිනේද? හරි. හරිද? Shall we continue? Question number 21. Have done. Question number 21. Done. Question number 21. Okay, as we have discussed several MCQ questions in our last two paper class today I have selected some essay type questions. Those questions are past paper questions. Therefore, I have selected those questions. So let me know if you completed this question. Whether you complete or not. Question number 21. Complete, no? Okay. I have asked to do question number 21, 26, and 40. Question number 21 and 26 are past paper questions. Okay. Okay. A 3.6 meter long light inextinguishable string is attached to a fixed support at its upper end and 2 kg mass is suspended from its lower end. This is 2 kg mass. Here 3.6 meter long string which is inclined 60 degree to vertical, and this one is 1 kg mass. Two kg mass is suspended from its lower end. Okay, when the string is vertical, the 2 kg mass is just touching a 1 kg block of wood on rough horizontal surface. Rough horizontal surface. Okay. The string is taken. The string is taken, pulled at an angle 60 degree to the vertical, and 2 kg mass is released. Find the velocity, the 2 kg mass, 2 kg object when the string becomes vertical. Ignore air resistance. That means when this object comes to this position, find the velocity. Find the velocity. So how to find the velocity? How to find the velocity? You know this length is 3.6. This height is 3.6 because this string is 3.6. Therefore, this one is some kind of circular path. So this is 3.6 meter height. Therefore, if you draw a perpendicular, this one is 3.6 cos theta, and this one also, that means 1.8. Therefore, that height should also equal to 1.8 meters. 1.8 meters. I'm gonna make it A, B, C, D. Yes, 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 yes. Now, it is very clear, BC. Now, this is a perpendicular. This is a perpendicular. BC is equal 3.6 cos 60. That means 1.8 meter. Therefore, CD also equal 1.8 meters. Then, you need to determine the velocity. You need to determine the velocity of this object, of this 2 kg mass, when the string becomes vertical. When the string becomes vertical. Okay, this is question number 1, no? Question number 1. So in such cases, you can apply energy conservation law. Energy conservation law. So if you take this one as potential energy 0 level, so initially this object had a potential energy only. Finally, it has only a kinetic energy only because now it is in potential energy 0 level. Now it is at potential energy 0 level. Therefore, initial energy means by energy conservation law, initial energy is potential energy, that means mgh is equal, finally there is no potential energy 0, but it has a kinetic energy half mv square. Half mv square. M to mv be cancelled out, therefore V is equal is square root 2gh. This relationship is very, very important relationship when it comes to MCQ questions. If you can remember this equation, you can directly take the answer. Is square root 2gh. In order to apply this equation, one point should be at the potential energy 0 level. Okay, 2gh. And therefore answer is square root 2g means 10, h means 1.8. That means 36. Therefore answer is 6 ms minus 1. If you got this answer, please raise the hand. If you got this answer, please raise the hand. Okay, very good. Very good. ඊළඟට බලන්න. If the 2 kg object comes to rest immediately, that means once they collide each other, 2 kg object comes to rest immediately after hitting with 1 kg block. What is the velocity with which the 1 kg object is start to move? Can the law of conservation of linear momentum be applied to this collision? Explain the answer. Explain the answer. Now, the second scenario. So once the object hit, once 2 kg object hit with 1 kg mass, it will stop with it. It will stop and 1 kg mass start to move with a certain velocity. With a certain velocity. And you are asked to determine that velocity. You are asked to determine that velocity. And you are asked whether the conservation of momentum be applied or not. What is your answer? What is your answer? Can we apply conservation of linear momentum? Can we apply the theorem? Because this is a rough surface, so can we apply? Yes, we can. Yes, we can apply. So what is the condition of applying linear momentum conservation? We can apply linear momentum conservation. Now this object, now 2 kg object, 2 kg object comes at a speed of 6 ms minus 1. Here there is 1 kg object. So once they collide each other, once they collide each other, is still this object, once the collision occurs, this object is at rest condition, stationary condition. Therefore, there is no friction force exerted on this object, Puti. As 1 kg object, as 1 kg object is in stationary condition, when the collision happens, there is no friction force exerted on this object. So that is the reason. Therefore, you have to apply linear momentum conservation just after the collision put it. So after that you cannot may apply, because after that this object may start to move. So when the object start to move, there will be a friction force exerted on this object with it. Therefore, after that, after some time, you cannot apply it. But when the collision occurs, this object is at rest condition. So there's no friction force exerted on this object. That is the reason. That is the reason. Did you get my point? Oh, yes, Ken. Did you get my point? If you get my point, please raise the hand. Okay, then you can write down that thing. Then you can write down that thing. As 1 kg object is in stationary condition, as 1 kg object is in stationary condition, when the collision occurs, There is no friction force. There is no friction force. There is no friction force exerted on 1 kg mass. There is no friction force exerted on 1 kg mass at the moment of collision. At the moment of collision. Therefore, we can apply conservation of linear momentum. Therefore, we can apply conservation of linear momentum theorem. Okay. Then initial momentum is 2 into 6 put A. 2 into 6, that is the initial momentum. So linear momentum conservation into this side. Initial momentum is 2 into 6 put A. Here momentum is 0. Finally, this one becomes 0. And you need to determine the velocity of 1 kg. This velocity is, the velocity is equal to the velocity just after collision. Just after collision. 1 kg into V. That means V. The V is equal to 12. Therefore, V is equal 12 ms minus 1. Therefore, V is equal to 12 ms minus 1. And question number 3. Question number 3. If 1 kg object travels 9 meters on the rough horizontal surface after the collision and comes to rest, what is the friction force exerted by the surface on 1 kg object? 1 kg object. බලන්න මොකක්ද කියන්නේ කියලා. Now what will happen? Now you know 1 kg object starts to move with a velocity of 12. Now, you know, 1 kg object starts to move with a velocity of 12 ms minus 1 to the 12 ms minus 1. Therefore, this object has a kinetic energy at that moment. Now, when the object starts to move, there will be a friction force exerted on this object. There will be a friction force exerted on this object. Now what will happen? Now this object will move into the right-hand side against this friction force. Therefore, it has to do a work against the friction force. Therefore, its kinetic energy decreases continuously. So, after a certain time, it will come to rest. It will come to rest. So, when the object comes to rest, what will happen? Its total kinetic energy is used to do a work against friction. Therefore, work done against friction should be equal to the kinetic energy at the beginning of the journey. Therefore, if this object moves simple as distance, work done against friction is equal Fs. Work done against friction is equal Fs. Kinetic energy is equal half mv squared. Therefore, this work done should be equal to the initial kinetic energy. This should be equal to the initial kinetic energy. Therefore, Fs means friction into is 9 meters. 9 meters is equal half. M is 1, which again 12 square 144. 144 again with 72. 144 over 2 is 72. 72 over 9 is 8. Therefore, F is equal 8 Newton. If you get my explanation, please raise the hand. Thank you. Then the fourth one, last one. Find the coefficient of dynamic friction between 1 kg object and the block. Now it is very easy. Dynamic friction is equal mu r pute. F is equal mu r. Now F is, we have calculated F, that is 8 Newton. Mu r means this reaction force, that means it is equal to the weight. It is equal to the weight. Here r, here mg. R is equal to the weight. Weight is 10 Newton. 10 Newton. Therefore, mu is equal 0.8. 0.8. If you got these answers, please raise the hand. If you got these answers, please raise the hand. मैं answers करता रहा तो सर. Very good. Okay, then question number 26, 1989 paper question. 1989 paper. Question number 26. Complete it very quickly. Question number 26. It is 1989. So 1989 question. 1989 question. 1989. Question number 26. Like that, sir. 26 से 40. Okay. Then my 1989 question. 1989 question. State the law of conservation of energy and law of conservation of momentum. Okay. You have write them, but no need to discuss the thing. Then look at the question. Okay. A sphere A of mass 2 kg is suspended from a fixed point by a string. As shown in the figure, it is lifted from its equilibrium position to a vertical height of 1 meter without slack in the string and then released from rest. Then at the lowest point of its path, it collides inelastically with another sphere D, of mass 1 kg, which is at rest on rough horizontal surface. After the collision, B slides forward and travels a horizontal distance of 1 meter before coming to rest, while A oscillates and forward from its lowest position to a vertical height 0.5 meter. Now, this mass is released from this position and comes to this position at a certain speed, collide with this object. Okay. Then, after the collision, this mass rises up to 0.5 meter and this object moves 1 meter along this rough surface, rough horizontal surface. Okay. So at this position, V is equal to 0. Here also, V is equal to 0. Calculate the speed of A just before collision. Just before collision, you need to calculate this velocity, that means VA. Sorry, A. This one. So, to calculate V, now it is very easy. As I mentioned you earlier, you can use conservation of energy. You have to take this one as potential energy 0 level. So if it is potential energy 0 level, initially this object had a potential energy only, no kinetic energy. After releasing of this object comes to this position, therefore it will come to the potential energy 0 level Kute. As it comes to potential energy 0 level, potential energy becomes 0 and it has a kinetic energy. Therefore, its initial energy is a potential energy only. Energy of energy conservation or apply growth. Initial energy is a potential energy only, mgh, and final energy is a kinetic energy only because now it is at the potential energy zero level. Half mv square. N12 will be cancelled out, therefore Vc equals square root 2gh. Now you have to remember this equation. Square root 2gh. Now G is 210, this one is 1 meter. Therefore, here is square root 2 times 10 times 1. Vertical height is 1. Therefore, root 20 means V is equal to root 5 ms minus 1. 2 root 5 ms minus 1. Oh my, or square root 20. Or square root 20. Then calculate the speed just after collision. Just after collision. Calculate the speed of A just after collision. This is inelastic collision. This is inelastic collision. So as it is inelastic collision, can you apply linear momentum conservation law? Can you apply conservation of linear momentum? Can you apply? Because this is an inelastic collision. As it is an inelastic collision, can you apply that law? Can you apply? Can you apply? Gandhi, listen. Listen. Nasit. Yasit. Jiret. Can you apply that law? Again. Elasit. I need answers. I need answers. Did what is your opinion? Can we apply linear momentum conservation? Yes, we can apply. Actually, if there is a sorry, actually, if it is a inelastic collision, then kinetic energy there will be a loss in kinetic energy, but momentum is conserved. Momentum is conserved. Therefore, no need to worry about that thing. Yes, we can apply. Yes, we can apply. So, as it is a inelastic collision, then what will happen? Now, this is 1 kg object, and here this one comes at a speed of v 2 root 5. Here 2 kg object go 2 kg now. So as it is a inelastic collision. So just after the collision, definitely these two objects will move together as a combined object. Is that clear? Sorry. As a combined object. Yeah. No, we cannot use this put because one thing, because just after collision, this object is with the string, no? With the string, therefore, we cannot apply this one, but we can use this energy conservation for this one to analyze the velocity of the object A after the collision. මෙයා ස්ට්‍රින්ග් එකක් එක්ක ඉන්න නිසා අපිට මෙතනදී ඒ කියන්නේ එහෙම වෙයි කියලා අපිට එකපාරට හිතන්න බෑ. Okay? Therefore, in this case, don't use this one. Don't use this one. Don't use this one. So, just after the collision, this object, that means object A, rise up to 0.5 meters, 0.5 meters above the equilibrium position. Therefore, definitely we can use energy conservation for A after the collision. Energy conservation for A after the collision. Energy conservation law for A after the collision. You have to mention it very carefully. You cannot apply energy conservation before the collision and after the collision. You cannot apply because now this is an inelastic collision. As it is an inelastic collision, we cannot apply energy conservation for these two occasions. But after the collision, energy of phase should be conserved. So you can apply energy conservation after the collision. So energy conservation for A after the collision. So here it has a kinetic energy. Initially it has a kinetic energy. So at this position, velocity becomes 0. That means it has a potential energy only, GH. M10 will be cancelled out. Therefore, VA is equal to square root GH. Again, same equation. H is 0.5. 2 into 10 into 0.5. Okay, that means VA is equal to square root 10 ms minus 1. Did you get my calculation? Did you get my calculation? I got 10 now. And calculate the speed of B. Calculate the speed of B just after collision. Calculate the speed of B just after collision. Go Mika. Right. Then follow. මෙයා 0.1 මීටර් යනවා කියලා කියන පුතේ Uh, at the lowest point, it's quite inelastically with uh, another sphere D of mass communication uses at first order of simplices. Okay, so you have to take this one as like this. Maybe Pute, do you have any question, Pute? Okay, Pute. Actually, we have write a table. Hmm? And we have write a table. No? Balance. Huh? So if it is a elastic collision, whether it is elastic collision or inelastic collision, whether it is elastic collision or whether it is an inelastic or elastic, we can use energy conservation. So, sorry. Conservation of linear momentum. Conservation of linear momentum. Linear momentum is conserved with it. Because there is no any other external force, the linear momentum should be conserved. But if it is an elastic collision, if it is an elastic collision, then we can apply kinetic energy also a constant. But if it is an elastic collision, kinetic energy is not conserved. It is not conserved. And therefore, we cannot apply energy conservation. We cannot apply initial kinetic energy is equal to the final kinetic energy for inelastic collision. That means for collision, Puti, kinetic energy of the system just before collision is not equal. Okay, kinetic energy of the system just before collision. Kinetic energy of the system just before collision is not equal to the kinetic energy of the system just after the collision for inelastic collision. Inelastic. But for elastic collisions, they are equal. They are equal for elastic collisions. Here you are asked to determine the velocity of B just after collision. Just after collision means actually just after collision they should move together, but this is attached to a string. This is attached to a string. Therefore, once it moves very little bit to this side, then definitely the contact should be lost. Contact should be lost because this is this object. Object B moves in a linear path. This will move in a circular path. This will move in a linear path. This will move in a circular path. Therefore, if it is an inelastic collision, definitely both objects should move together after the collision. So after the collision, they will move together. But here, this one is attached to a string. Therefore, this one moves in a circular path. This object moves in a linear path. Therefore, we cannot accept the thing. And we cannot assume these two objects moves together. Okay. Is that clear? Hey, Runad. පැහැදිලිද ඒක? Hey, Rena Susanapute, if you got that thing, please raise the hand. initially object A moves with square root 20 ms minus 1, and this was at rest condition. But after the collision, this will move into this side, this will move into this kind of path. Yeah, okay, path again. Therefore, we cannot assume these two are moving together after the collision. That is number one. But yet, we can apply linear momentum conservation. We can apply linear momentum conservation. And so if we apply linear momentum conservation, to this side, initially this object was moving at a speed of v. V means this speed. mv. mv means what are here? Here 2 kg with 2 kg into v. That means 2 times root 20. That is the momentum of this object. මේක පුතේ මෙහෙමයි. Just after collision, just before collision කියලා කියන්නේ පුතේ මෙහෙම දෙයක්. ඒ කියන්නේ මෙතන මොකක්ද? අපි ගත්තොත් එහෙම මේවනේ බලන්න හැමෝම just before collision කියලා කියන්නේ බලන්න මෙයා කෙලින්ම දැන් මෙයා මොකක්ද when this object comes to this position, what will happen? This string becomes vertical. So according to the figure, when the collision occurs, this string becomes vertical. So that is the moment just before collision. And so this is the moment of just before collision. So just after collision means, so after the collision, definitely, so this is the point of collision. So after the collision, what will happen? This is inelastic collision. Definitely, this one will move in linear path, while this one moves in this kind of path. And then දැන් උත්තර ප්‍රශ්නේ තියෙන්නේ මෙයා circular path එකක යනවා මෙයා linear path එකක යනවා. ඕකනේ ප්‍රශ්නේ තියෙන්නේ. එහෙම නැතුව තිබ්බොනම් ඒ කියන්නේ මෙයා මේ දෙන්නා මේ විදිහට collide වුණා නම් so this is just before collision. There is no velocity for this one. So just after, definitely they will move together. Just after, because this is inelastic collision. Is that clear? Again? Perfectly inelastic නැද්ද කියලා මේකේ දීලා නැහැ. Perfectly inelastic නැද්ද කියලා දීලා නැහැ. එතන ඒක නිසා තමයි අපි ඒක කන්සිඩර් කරන්නේ නැත්නම් අපිට ඒක අවශ්‍ය නැහැ. හරි අපිට මේ ක්වෙස්චන් එක හදන්න ඒක අවශ්‍ය නැහැ. ඒ වර්ඩ් එක දීලා නැහැ. Perfectly inelastic නැද්ද කියලා අපිට මේකේ වර්ඩ් එකක් දීලා නැහැ. හරිද? සමහර වෙලාවට මේක perfectly කතන්දරේ කියන්නේ නැතුව inelastic කියන කතන්දරේ කියනවා. හරිද? ඒවට perfectly inelastic වුණොත් තමයි ඉතින් මේක මේ විදිහට යන්නේ. ඒක දීලා නැති නිසා තමයි අපි මේක කන්සිඩර් කරන්නේ නැත්තේ. හරි. ඒ නිසා කොහොමවත් ඕක අර 100% perfectly inelastic එකක් වෙන්න බෑ. මොකද මෙයාවත් අර එකට කම්බයින් වෙලා යන්නේ නැති නිසා. එකට කම්බයින් වෙලා යන්නේ නැති නිසා 100% perfectly inelastic කියලා ගන්න බෑ අසලට. ඒක දීලත් නැහැ අතන. දීලත් නැහැ ගන්නත් බෑ. දීලත් නැහැ ගන්නත් බෑ. හරි. මොකද සමහර ඒවා තියෙනවා සමහර වෙලාවට perfectly කියන වචනේ දෙන්නේ නැහැ. නමුත් අපිට සමහර වෙලාවට මේ ඒ දීලා තියෙන ෆිගර් එකත් එක්ක හරි මේක perfectly කියලා හිතන්න වෙන වෙලාවල් තියෙනවා. එහෙම කතන්දර තියෙනවා. නේ හැබැයි මේක perfectly inelastic කියලා දුන්නා නම් අනිවාර්යෙන් ඒක අනිවාර්යෙන් මේ වචන ටිකක් බරපතලයි. ඒක අනිවාර්යෙන් යන්න ඕනේ. අනිවාර්යෙන් මේ දෙන්න එකට යන්න. මේ දෙන්න මෙතන එකට යන්නේ නැති නිසා තමයි. මෙයාවත් එකට යන්නේ විදියක් නෑ. මොකද මෙයා යන්නේ ලීනියර් පාත් එක. මෙයා යන්නේ සර්කියුලර් පාත් එක. හරිද? ලීනියර් පාත් එක මෙයා යන්නේ සර්කියුලර් පාත් එක. දැන් මෙතන එකම ප්‍රශ්නේ මේක පොඩ්ඩක් ලොකු වෙලා දාලා පොඩියට ඉඳලා එතකොට අර ලොකු වෙලා ඉඳලා පොඩියට යන ගමන් එකපාරට හිතෙන්න පුළුවන් පොඩි වෙලාවක් හරි ටච් වෙලා තියෙන්න පුළුවන් කියලා. හරිද? නමුත් ඔය දෙන්නම එකම සයිස් එකේ යනවා කොහොමද එහෙම හිතෙන්නේ නැහැ. හරිද? මොකද මේක ලීනියර් පාත් එක යනකොට මූ තවත් ලීනියර් යන්න බැහැනේ පුතේ. මොකද අපි සාමාන්‍ය සර්කල් එකක් කරනකොට නේ මෙන්න සර්කියුලර් පාත් එක. සර්කියුලර් පාත් එකේදී මෙයා මෙතන ඉන්නේ මේ පැත්තට යන්නේ මෙන්න මේ අවස්ථාවේ. ඊට පස්සේ මූ මෙතනදී මේ පැත්තට යන්නේ. නේ? එහෙම යන්නේ. අනිවාර්යෙන් මේ දෙන්න එකට ටච් වෙලා මහ ලොකු වෙලාවක් ඉන්නේ කොලිෂන් එකේ වෙලාවක් තමයි ටච් වෙලා ඉන්නේ. කොලිෂන් එකෙන් පස්සේ අපිට ටච් වෙනවා කියලා හිතන්න බෑ. ඒ නිසා තමයි මේක perfectly inelastic කියන වර්ඩ් එක දීලා නැත්තේ. perfectly inelastic කියන වර්ඩ් එක දීලා නැත්තේ අන්න ඒක. එහෙම නැත්නම් ඉතින් අනිවාර්යයෙන් දෙනවනේ. මේ perfectly inelastic නම් අනිවාර්යෙන් ඔතන කතන්දරයක් තියෙනවා අනිවාර්යෙන් යන්න ඕනේ. ඒකෝ අනිවාර්යෙන් යන්න ඕනේ. හරි. ඒ නිසා ඒ වර්ඩ් එක දීලා නැහැ. ඒ නිසා අපි ඒක ගන්නෙත් නැහැ. අවශ්‍ය ඒ නිසා තමයි ඉනිලාස්ටික් කතන්දරේ තිබ්බා වුණාට ඒක අපි ක්වෙස්චන් එකට ගාව ගන්නේ නැත්තේ ක්වෙස්චන් එකට අවශ්‍ය වෙන්නේ එනර්ජි ලොස් එක කැල්කියුලේට් කරනකොට විතරයි. පැහැදිලිද? ඒකයි අපි තේරුම්ම ලීනියර් මොමන්ටම් කන්සර්වේෂන් එකේ යන්නේ. මොකද ලීනියර් මොමන්ටම් මේක කන්සර්ව් වෙන්න බෑ පුතේ. ලයික් වෙනවා. ලීනියර් මොමන්ටම් මේක කන්සර්ව් වෙන්න ඕනේ. අනිවාර්යයෙන් ලීනියර් මොමන්ටම් කන්සර්ව් වෙන්න ඕනේ. ඒක නිසා තමයි ලීනියර් මොමන්ටම් එක කන්සර්ව් කියලා හිතලා ඒක හිතලා නෙවෙයි අනිවාර්යෙන් කන්සර්ව් නිසා ඒක ඔස්සේම ක්වෙස්චන් එක දන්නේ ඒක. පැහැදිලිද? තේරුණා? මොකද අපිට ඉනිලාස්ටික් කොලිෂන්ස් වලදී අපිට හදන්න බෑ. දැන් මැක්ස් ගන්න කට්ටියට හදන්න පුළුවන්. මොකද අපි සාමාන්‍ය සිම්පල් ඊව් කියලා වැලියු එකක් ගන්නවා. මේ ඒ වැලියු එක 0 කරලා හදන්න පුළුවන්. නමුත් ෆිසික්ස් වලදී අපිට ඉනිලාස්ටික් කොලිෂන්ස් වලට අපිට මේ අර ඉතුරු ඉක්වේෂන්ස් දාන්න බෑ. අපි ගන්න පුළුවන් එකම දේ අපි දන්න එකම දේ අපිට තියෙන එකම රිලේෂන්ෂිප් එක මොකද්ද? මොකද්ද? ලීනියර් මොමන්ටම් කන්සර්වේෂන් එක. ලීනියර් මොමන්ටම් මතක තියාගන්න ඉනලාස්ටික් කොලිෂන්ස් වලදී ඕගොල්ලන්ට ගන්න පුළුවන් එකම එක රිලේෂන්ෂිප් එකයි තියෙන්නේ ලීනියර් මොමන්ටම් කන්සර්වේෂන්. Okay. You have to may go through the table which I have given you when we are doing collisions with it. When you are doing collisions. So there are three types of collisions. Elastic, perfectly inelastic. No. Remember this one. For any collision, inelastic or perfectly elastic, we can use linear momentum conservation if there is no external force. If there is no external force, we momentum, because linear momentum depends on the presence of external force or not. But energy conservation, we cannot apply energy conservation for any other collisions rather than elastic. So if it is elastic collision, then we can apply energy conservation. But if it is not, we cannot apply energy conservation for the collision. For the collision means applying energy conservation for collision means kinetic energy of the system before the collision is equating the kinetic energy of the system just after the collision. We can do that for elastic collisions only. For other than elastic collisions, we cannot use that relationship. So we have to use linear momentum conservation only. Linear momentum conservation only. Is that clear? If it is clear, please raise the hand. Gandhi have to put it. Very good question. බලන්න. අයි මෙතනට මම ECL එක දැම්මේ energy conservation law එක. පුතේ මෙතන මම මේක අපරාධ මම මේකේ ෆිගර් එක ඇඳලා හොඳයි කියලා හිතනවා. මම මෙතන ෆිගර් එක මම අර පැත්තේ දින්නවා. කම නැද්ද? මෙතන ෆිගර් එක මම අර පැත්තේ දින්නා. හරි. මෙතන ෆිගර් එක ඇඳලා හොඳයි කියලා හිතනවා. මේක තමයි ප්‍රශ්නේලා තියෙන්නේ. හරි. Okay, look at this one. So just after collision, this will move in circular path. This will move in straight line. Then, so after the collision, now, so this is just after the collision. Okay? This will move in a straight line, and this will move in a circular path. This object means object A will move in a circular path just after collision. Just after collision with a certain velocity. I don't know that velocity, but with a certain velocity, it will move. Okay. Now, put පොඩි වෙලා දෙන්න කෝල් එක. Okay. Now, Now there is no collision after this. Look at this one. Now this is after collision. This is after collision. So after the collision, this object will move in a straight line. Then this object will move at a certain speed, with through a. Therefore, according to the energy conservation, kinetic energy of this object should be conserved. There is no any other resistant force. Right? Just after the collision, this object will not collide with any other. So after the collision, this object moves in this circular path. So after the collision, this object will not collide with any other object. Therefore, its energy should be conserved. Is that clear? Actually, I have equated the energy just after the collision. Just after the collision. I have not equated the energy before the collision and after the collision. Collision එක වෙන්න කලින් energy එකයි පස්සේ energy එකයි නෙමෙයි මම equate කරේ. collision එක උනාට පස්සේ මොකක් හරි energy loss එකක් වෙනවනේ. මොකක් හරි energy loss හිතන්නකො මෙයාගේ තිබ්බා 100 joule energy එකක්. මෙතනදී loss වුණා පුතේ 20 joule. ඊළඟට 80 joule remaining නේ. ඒ remaining 80 joule එක cancel වෙන්නේ බෑ. හරිද? අන්න ඒ remaining energy එක තමයි cancel කරේ. හරි? Is that clear? Then you need to determine the calculate the speed of V just after the collision. Now, initial momentum. This is the initial momentum of the system. Initial momentum of the system is mass is 2 kg, speed is √20. Therefore, initial momentum just before collision, the momentum is 2 into V. 2 into V means 2 into √20. 2 into √20, that is the initial momentum. Initially, this object had no momentum, it is at rest condition. Then after the collision, this object will move at a speed of VB, that means 1 into VB plus simple A will move at a speed of VA means √10. 2 into √10. 2 into √10. And I'm making a method again, and therefore VB is equal 2 times √20 minus √10. √20 minus √10. √20 can hear. √20 means 4 point something. 4 point something, no? Yes. 20. 4.5 4.5. This one is 3.1 again. This one is 3.1. This one is 4.5. 4.5. 3 point. Yes, 4.5. 3.1 again. 3.1. 3.1. Sorry, 4.5 minus 3.1. 4.5 minus 3.1 means 1.4. Sorry, 1.4 again. Two into 1.4. This is approximate figure only. This is approximate figure. 32 කියන කීයද? 32 එනවා. Approximately PB is equal to 2.8 ms minus 1 kilogram. This is approximate figure. Approximate figure. හරිද? Did you get my calculation? If you get my calculation, please raise the hand. Right. Then, what is the loss of kinetic energy in A? What is the loss of kinetic energy in A due to the collision? What is the loss of kinetic energy in A due to the collision? Initially, it had a speed of √20. Now it has only √10. Initially √20, now it has only √10 පුතේ. Therefore, kinetic energy lost. Kinetic energy lost, different is kinetic energy is equal half mv1 squared minus v2 squared. Initial speed is √20, therefore half m is 2, √20 squared means 20 minus √10 squared is 10. Therefore, answer is 10 joule. Answer is 10 joule. Is that clear? If it is clear, please raise the hand. Then question number 5. Question number 5. Is the loss equal to the kinetic energy gained by B? Is the loss equal to the kinetic energy gained by B? Give reasons for your answers. Give reasons for your answers. Question. Now there's energy loss. Now there's an energy loss of A. Is that energy loss equal to the energy gained by B? Energy gained by B. Energy gained by B. Energy gain එක බලමු නේ. බලමු. Energy gain. That means different is kinetic energy in B is equal half mv squared. Half mv squared because initially it has no energy. It has no kinetic energy. Therefore, this is equal half mv squared. Therefore, this one is half. M is 1. That is equal to 2.8 square. 2.8 square. Therefore, it is very clear that 2.8 square means it is lesser than 10. And it is divided by 2 means definitely this is lesser than 10. Therefore, definitely this one is lesser than 10 joule. This one is lesser than 10 joule. Therefore, kinetic energy loss in object A is not equal to the energy gain in B. Energy gain in B. That means there is a permanent loss of kinetic energy. There is a permanent loss of kinetic energy. And so if you consider about this one as 3 and if you consider about this one as 3, then this value should be 4.5. Therefore, approximately, actually not approximately, more than half of this kinetic energy. More than half of this kinetic energy is lost. And therefore, there is a kinetic energy loss. So what is the reason? The reason is this collision is inelastic collision. This collision is an elastic collision to the. This collision is an inelastic collision. It is inelastic collision to the. Therefore, definitely there will be a kinetic energy loss. Definitely there will be a kinetic energy loss. Did you get my point? If you got that point, please raise there. Find the coefficient of dynamic friction between B and rough surface. Find the coefficient of dynamic friction between B and the rough surface. Harry, I had to erase this one. You know, according to the data, object B has moved 1 meter along this rough surface. 1 meter along this rough surface just before rest condition. That means before it comes to the rest condition, it moves 1 meter along the rough surface. Therefore, work done against friction should be equal to the initial kinetic energy. Work done against friction should be equal to the initial kinetic energy, because when the object moves in this side, there will be a friction force into the other side. Therefore, when the object moves into this side, definitely it has to do a work against friction. It has to do a work against friction. The work against friction should be equal to F into S, force into displacement. And that energy is provided by its initial kinetic energy. Therefore, when there is a work done against friction, its kinetic energy should be decreased. Therefore, when the object comes to this condition, its kinetic energy is fully consumed to do a work against friction. Fully consumed to do a work against friction. Therefore, Fs means work done against friction should be equal to the initial kinetic energy, means kinetic energy of the object B. Now I don't know friction force is mu r, no? Sorry, mu d, right? Mu r is equal half mv square. mv square again when they make it square. Then square they are not only read about. Maybe square analysis. Mu, put a R means mg. R is equal mg, no? R is equal mg. Therefore, this one is mg. Mg S is equal half mv square. Therefore, m to mv will be cancelled out. S is 1 meter. S is 1 meter. Therefore, mu is equal. This one is 1 meter. V square means 2.8 squared over 20. 20. 2.8 squared over 280. 20. You see it, I see it. That's it is there, is setting at the top of people. 7.8. Mu is equal 0.39 kilo. 0.39. 0.39 kilo. Is that clear? If you got this one, please raise the hand. If you got this one, please raise the hand. Okay, thank you for that. This is 1989 question. This is 1989 question. 1989 question. Pute, before go to the question number 40, please do 34. Question number 34. That also may uh, exam question. Take the exam question. 34 ka 34. Now we are doing exam questions. Past paper exam question 1993 exam question. Question number 34. 1993 exam question number 34. Please do it very quickly. Oh, you did. Have finished? Thank you. Thank you, Andy. Ahí está, Pati. Ada. Ada betul. Bang Opi. බලන්න කලින් මම පොඩ්ඩක් ආසක් මොකක්ද මතක් කරන්නේ. මොනවද මම කිව්වා අපි එක්ස්ට්‍රා ක්ලාසස් එකක් දාගන්න ඕනේ කියලා. එදාට ගොඩක් වෙලාවට මට ගොඩක් ළමයි මට ෆ්‍රී කියලා කිව්වේ වෙන්ස්ඩේ. වෙන්ස්ඩේ එන්න බැරි දරුවෝ ඉන්නවා නම් මොකක් හරි හේතුවක් නිසා මට වෙනම එක මැසේජ් එකක් දාන්න. ඕගොල්ලන්ගේ ෆ්‍රී ඩේස් එක නිකන් දාන්න එපා. ඒ කියන්නේ තමු වාර ෆ්‍රී දවසක් තියලා ඒකත් එක්ක දාන්න. වෙන්ස්ඩේ. හරිද? මේ දැනට හොඳේ දැනට අපි ඒක අපි දාගමු. මොකද අන්තිමට ඒකත් නැතුනොත් එහෙම වෙන කතන්දරයක් වෙන නිසා. හරිද? මොකක්ද මේ වීක් එකේ මම පොඩ්ඩක් බලනවා මේ වීක් එකේ නෙවෙයි මම ඒක දරුම් දෙන්න ඕන කවුරුද පටන් ගන්න කියලා. මේ මොකද්ද මේ වීක් එකේ වෙන්ස්ඩේ පුළුවන් වුණොත් මම කියන්නම්. හැබැයි මට මේ වීක් එකේ මම ෂුවර් එකක් නැහැ. මොකද මේ 25 කට්ටිය කැන්ඩිඩේට් කරන නිසා බැරි වෙලා හරි පුළුවන් නම් වෙන්ස්ඩේ පටන් ගත්තොත් අපි යන්නේ මේ නයිට් ක්ලාස් එක කියලා කියන අපිට පටන් ගන්න වෙන්නේ පුතේ around 7:38 වගේ තමයි පටන් ගන්න වෙන්නේ. අපි එහෙම වුණොත් එහෙම 2.5 hour or 3 hour මේ සෙෂන් එකක් තමයි අපිට කරන්න වෙන්නේ. නෑ ඒක අවුලක් නැහැ. මොකද අපිට ෂේප් එකේ ලෙසන් එක අරගෙන යන්න පුළුවන්. මේ වීක් එකේ මම පොඩ්ඩක් බලන්න මේ වීක් එකේ මට පුළුවන් වුණොත් මම කරන්නම්. මේ වීක් එකේ කරොත් ගොඩක් වෙලාවට ඒ ලෙසන් එක ඔයගොල්ලන්ගේ මේ පාර එක්සෑම් එක ටාගට් කරලා මම ඔයගොල්ලන්ට ඒ වෙනුවෙන් කරන්න මේ වීක් එකේ කරන්න පුළුවන් වුණොත්. හරි. මේ ඊට පස්සේ එක්සෑම් වලට පස්සේ ගණක් නෑනේ. ඊට පස්සේ මුතේ එතකොට මේ අපේ ක්ලාස් ඇරේන්ජ්මන්ට් එක සකස් වෙන්නේ මතක තියාගන්න මේ ඔය මොනවද මේ ටර්ම් ටෙස්ට් එක්සෑම් ටික ටාගට් කරලා නමුත් මගේ අපේ මූලික අරමුණ වෙන්න ඕනේ ප්‍රධාන අරමුණ A-level exam එකනේ පුතේ. එතකොට A-level exam එකට ඔයගොල්ලන්ව කොහොමද ඉක්මනින්ම ප්‍රෙපෙයාර් කරන්නේ කියන දේ තමයි මම බලන්නේ. ඒක ඇතුලේ තමයි අපිට ටර්ම් ටෙස්ට් වලට එහා මෙහා අපිට කරගන්න වෙන්නේ. මේ ඒ නිසා A-level exam එකට යන්න පුළුවන්. ඒ කියන්නේ ඉක්මනින්ම සිලබස් එක කවර් කරගන්න පුළුවන් පාත් එක ඔස්සේ තමයි මම මේ වැඩේ කරන්නේ. හරි. ඒ නිසා අර මුල ටික අපි කතා කරනකොට මුල ටික පොඩ්ඩක් අපිට ටිකක් ඇදෙන ගතියක් තියෙනවා. නමුත් ඉතින් මේ ඕක අනිවාර්යෙන් ක්ලාසස් number of classes ගන්න වැඩි වෙද්දී ඕකේ එහෙමම අයින් වෙලා යනවා. මම කිව්වා වගේ දැන් 25 කට්ටියට ලොකු ෆ්‍රී එකක් අපි දීලා තියෙන සහ ඇවිල්ලා තියෙන්නේ මොකද සිලබස් එක ඕල්මෝස්ට් කවර්. හරි. ඒ නිසා මේ අපි මේ මට ඒක නිසා ඕගොල්ලන්ගේ මම ආශාවක් ඉල්ලන්නේ වෙන්ස්ඩේ ඔය කියන ටයිම් එකට ඒ ගන්න බැරි දරුවෝ මට කීප දෙනෙක් මට කතා කරලා කිව්වා සහ ටයිම් දුන්නා මේ අනිත් අයත් පොඩ්ඩක් එහෙම බැරි නම් මට මේ ෆ්‍රී ටයිම් දෙන්න. එතකොට එහෙම ළමයි යන්නලා වෙන දවසක් දාගන්න පුළුවන්. හරිද? මේ හැබැයි එතකොට එකම ලෙසන් එක තමයි දවස් දෙකක් තියෙන්නේ. එතකොට ඒ දවස් දෙක තුළ ඕගොල්ලන්ට කැමති දවස් සිලෙක්ට් කරගන්න පුළුවන්. හරි. හරි. Bala. Okay, Bhuti. Let's do the question number 34. 34, bala. Question number 34, that is the exam question. 1993, 1993 exam question. Okay. Explain the difference between elastic and inelastic collisions. So, what are the difference between elastic and inelastic collision? Tell me quickly. Then you can actually you can make a table. Then it is very easy to express your information. Right? Then elastic collision. Elastic collision. During the elastic collision, elastic collision means during the elastic collision, kinetic energy will be a constant. But in elastic collision, kinetic energy will not be a constant. There will be kinetic energy lost. There will be kinetic energy lost. Difference nihan? What difference? Then give an example of perfectly inelastic collision. So what is the example? What is the example for perfectly inelastic collision? Okay. Drawing a clay ball on a floor, onto the floor or onto the wall. අපි clay ball එකක් ගැහුවොත් මොකද වෙන්නේ? අනිවාර්යයෙන් ඒක ඩොක් ගාලා ඉවරන අතරින් එහාට යන්නේ නැහැ. So that is a inelastic collision. Perfectly inelastic collision. Drawing a clay ball into the ground. 3 trolleys A, B, and C, masses 1 kg, 1 kg, and capital M respectively are placed at rest on a frictionless horizontal surface. Trolley A is projected towards B with a velocity of capital V, as shown in the figure. Assuming that all collisions are elastic, show that after trolley A collides with B, A stops and B start moving with the velocity V. Now you know if there's a collision, with same masses, if there's an elastic collision with same masses, the velocities exchange each other, no? Velocities exchange. Therefore, if there is an elastic collision, this is 1993 question. So if there's elastic collision, between two objects, having same mass, their velocities will be exchanged. V1, V2. So after the collision, this will move with V2, this will move with V1 speed. Velocity is smaller. So if one of them is at rest condition, then after the collision, the second one will be come to the rest condition. The other object will move. That means, suppose this object is at rest condition, as their masses are equal, once they collide each other, this mass will come to the rest condition, and this mass starts to move with the velocity of this mass. Okay. Then බලන්න අපි කොහොමද ඒක ප්‍රූව් කරන්නේ? කවදාද අපි ඒක ප්‍රූව් කරන්නේ? We can prove, no? Now here trolley A1, so trolley A with 1 kg mass moves with the velocity of v collides with another trolley of same mass. This collision is an elastic collision. Now, as it is an elastic collision, we can apply linear momentum conservation law. Linear momentum conservation law to this side. Then initial momentum is v putih. Final momentum. Kita ada ngutin A, mega B. This one is VA, this one is VB. The final momentum is equal VA plus VB because mass is 1 VA plus VB. This is number 1. Then we can apply energy conservation as it is an elastic collision. Energy conservation law to this side. Then initial energy is half mv squared. That means half v squared is equal, final energy is half va squared plus half vb squared. Half, therefore, v squared is equal va squared plus vb squared. vb squared. Okay. If I take this one to this side, you will have v squared minus va squared. V squared minus va squared. That means difference of square. For the difference of square, then I can write it as v minus va, v plus va is equal vb squared. Then I can subtract vb from here. From 1, vb is equal v minus va, v minus v, v minus va, v minus v, then v minus v. Therefore, vb squared is equal v minus va squared. V minus va squared. And then I can apply this one to here. Second from 2 to A. From 2 to A. Then V minus VA into V plus VA is equal VB squared means V minus VA. V minus VA is squared. Then 1V minus VA to 1V minus VA will be cancelled out. Therefore, V plus VA is equal V minus VA. V to V will be cancelled out. Therefore, VA is equal 0. VA is equal 0. V to V will be cancelled out. Then VA will be equal to 0. So, as VA is equal to 0, VB becomes V. Therefore, from 1, as VA is equal to 0, VB becomes equal V. Therefore, after the collision, object A comes to rest while object B will have the velocity of A. Is that clear? If it is clear, please raise the hand. Okay. Then second one. මේවා මේ අර මතක තියාගෙන prove කරන්න දැනගෙන ඉන්නවා මේ. If m is equal half kg, capital M, that means object C. Show how many collisions will occur and find the final velocity of all trolleys in terms of P. Sorry. Okay. Now you know VA is 0, VA is 0, therefore question number 2. Now VA is 0, now therefore it will have press condition, it will have press condition. It will have press condition. Then B moves into C. B moves into C with the velocity of V. Mass of B is 1 kg. Then here there is C. C is a press condition. Its mass is 0.5 kg. Now, after the collision, you have to find VB and VC. After the collision, you have to find VB and VC, because if there is a chance, if there's a chance of rebouncing, if there's a chance of rebouncing VB, then VB will come to this side. Then again it will collide with A. Then again it will collide with A. Then there will be another collision with it. Therefore, we have to determine whether actually where's the direction of VB, where's the direction and magnitude of VB as well as VC. But as the mass of this object is higher, then definitely after collision, the speed of C should be higher than the speed of B, and both should be into the same direction. And they can be there, no, pin only make I kill. Here is the balance. Therefore, if I apply linear momentum conservation, to the linear momentum conservation to B and C, to this side, initial momentum is 1 into V, that means V. Final momentum is 1 into VB, here 0.5 into VC. 1 into VB, 0.5 into VC. That means VB plus 0.5 into VC. I can multiply both sides by 2, then it will become 1. Therefore, 2V is equal to VB plus VC. Then I can apply energy conservation to determine another relationship. Kinetic energy just before collision. Kinetic energy just before collision should be equal to the kinetic energy just after the collision. Therefore, if I apply energy conservation law, kinetic energy just before collision is equal half mv square. Half m is 1 v square is equal kinetic energy after the collision means half m is 1 vb square plus half M is 0.5 VC square. Half to half to half will be cancelled out to 3. Therefore, then this I can multiply both sides by 2 putih. Make 2 will multiply karo 2v square is equal to vb plus vc square. Alright. I can subject VC. I can subject VC from this side. I can subject VC from this side. පුතේ මේක අර මේ හදන්න පුළුවන් මොකද්ද මේ මොකද්ද මේකේ මොකද්ද මේ if you are given a MCQ question like this you can do this question using the other relationship. What is the relationship? Relative velocity of approaching. Relative velocity of approaching should be equal to the relative velocity of leaving. That's separation. Relative velocity of approaching should be equal to the relative velocity of separation. Taking හදන්න පුළුවන්. හරිද? මේකේ හදලා ලේසියෙන් ගන්න පුළුවන් MCQ question එකක් නම. හැබැයි MCQ question එකක් නම් විතරයි. මම කොහේ ඒක යූස් කරන්න එපා essay questions වලට. essay questions වලට අපිට අනිවාර්යෙන් මේ දෙක තමයි යූස් කරන්න. මොකද ඒක අපිට සිලබස් එකේ නෑ. ඒක අර මැත්ස් කරන කට්ටියට තියෙන එකක්. මම ඒක කියලා දුන්නේ ඔය ටග් ගාලා අරගන්න. හරිද? මම ඒකිනුත් මේක හදලා පෙන්නන්න. ඒකිනුත් මේක හදලා පෙන්නන්න. හරි. Then we can apply so we can subject VC from here. VC from here, then apply to that side. Apply to that side. Lazy that. Lazy duck. Abang kita ni mereka square and lazy. Difference of square gum. So if I take this one to this side, then 2 times difference of squares v minus vb v plus vb is equal vc square. Vc square. Then vc is equal 2 times v minus vb. 2 times v minus vb. Therefore, I can apply it to here. Therefore, 2 times v minus vb, v plus vb, that is equal vc. Vc means 2 times v minus vb. 2 times v minus vb, you have to take the square. 2 times v minus vb means 4 times v minus vb square. 4 times v minus vb square. Therefore, this one will be cancelled out today. Here to here 2. Therefore, v plus vb is equal to v minus 2vb. Therefore, vb, you can take this one to here. Remember again, vb is equal v over 3. vb is equal v over 3 into this side. In this side. Is that clear? If you get my calculation, please raise the hand. If you get my calculation, please raise the hand. එහෙනම් v දාන්නවා නම් පුතේ v over 3 කියලා v දාන්නවා නම් you can apply to this side. You can apply to this side, then take it to here. Here v over 3, if you take it to here, it will become here v over 3. If you take it to here, it will become 2v over 3. 2v over 3 into half. Therefore, VB, so VC is equal 4v over 3. 4v over 3 into the same direction. Then there are only two collisions. Altogether, two collisions. One is A with B, A and B. Other one is B and C. Those are the two collisions. Because after the collision with A, after the collision with B, C will start to move at a higher speed than B. Therefore, speed of B is higher than B. That means C will move faster than B. Therefore, B and C will never collide again. You have read that one. As VC is higher than VB. B and C will never collide again. Therefore, there are only two collisions. One is A and B, other one is B and C. That is the answer. Have V8 දාන්න නම් V8 is 0. V8 is 0. නැත්නම් මෙහෙම දාන්න පුළුවන් after collision with A and B there are only one collision which is in between B and C. That's also correct. Or else you can write there are two collisions in between A and B, and after that B and C. හැබැයි ලියන්න ඕනේ අනිවාර්යෙන් මේක. එක හරම note එකක් දෙන්න. මේ දාන්න. As VC is higher than VB. B and C will never collide again. Therefore, there are only one collisions after the collision between A and B. Therefore, there is only one collision after the collision between A and B. So when you are, everyone please look at me. So when you are doing calculations in this kind of questions means if we apply both linear momentum conservation, and energy conservation, it is very easy to use difference of squares to solve these two equations, because one equation has only actually power. This power is single power equation to this one. Okay, but this is a quadratic equation, and therefore, uh, to solve this kind of equation, it is very easy to use uh, difference of squares if it can be applicable. Applicable නම් කරන්න පුළුවන්. නැත්තම් කරන්න බෑ. But if we can use, you can use difference of squares to solve this kind of questions very easily. Now you can see, Pute, if you are given this kind of question in MCQ paper, and if you use this method, then you cannot do any other question rather than this question, no? Because this calculation is too low. So, in order to reduce the calculation, I will teach you another short method, but this is a combined maths method, Pute. Therefore, you cannot use this one in essay paper. And make a combined maths students වල කරන දෙයක් මේක මේ නිසා මේ පොඩ්ඩක් ඒක අපිට මේ physics වලදී use කරන්න බෑ, that we can do calculations with very easily. මොකද combined maths වල මේවා පුතේ අර අපි කියන්නේ දඩාර පාඩම් කියලා. ඒ දඩාර පාඩම් කියලා කියන්නේ අපතන මේ ඉස්සර මේ papers ගත්තොත් එහෙම ගොඩක් වෙලාවට හොඳ questions එන ඒ කියන්නේ ගොඩක් හොඳ questions එන පාඩම්. ඒ නිසා අපි කියන්නේ combined maths student කෙනෙක් ගත්තොත් ඉතින් මේවා අර හදලා නිකන් අර මේ වගේ question එකක් දෙනවා කියන්නේ ඉතින් මේ අර බොහෝම අඩු මට්ටමේ question එකක්. ඒ කියලා මම නෝ කරනවා නේ. නමුත් ඒක තියෙන මේ equation එක. يعني ඒ මාසිය උතන්ට ගන්න පුළුවන්. හැබැයි ඉතින් මේවා විතරයි. එතනින් පස්සේ සිම්පල් හාමොනික් මෝෂන් වලින් පස්සේ ඉතින් ආ ඩොක්ම තමයි ඉතින්. දෙගොල්ලෝ ඒක අනේ වාසිය ගත්ත කියලා වැඩක් නැහැ නේද? වාසිය ගන්න වෙන්නේ කම්බයින්ස් කට්ටියත් එක්කමනේ. ඒ නිසා ඉතින් මේක එහෙම වාසියක් නෙවෙයි. Okay. Shall I guess? Shall I guess? This one. මේක දහන්න පුතේ ගන්නේ. මේකද මේකද? මේකනේ. මේක. Okay, I will explain again. I will explain again. බලන්න. මේක මේ easily දාපු ගන්නේ පුතේ. දැන් easily දැම්මම පස්සේ look at this one. This is half m v squared, m is 1. හැමෝම අහගන්න. m is 1, therefore no need to write m. Half m v squared, half m is mass of b, that is 1. Then, so this is the energy just before collision. Just before collision, there is a velocity for b only. Therefore, kinetic energy of b is equal half mv square. There's no kinetic energy for c. Then after collision, kinetic energy of b is equal half mvb square. Kinetic energy of c is equal half m is 0.5 vc square. Is that clear? Is that step is clear? Is this step clear? Then from here, you know this one is half to half to half to half will be cancelled out. But there here, another half here, there's another half here. So you can eliminate that half by multiply every term by 2. If you multiply every term by 2, what will happen? This will be 2, this will be 2, 0.5 into 2 means 1. So that is step number 2. Is that clear? Step number 2. Lagina. Tam lagina. Tam lagina. පොඩි වෙලාවක් දෙන්න මොකද මේක මට තේරෙනවා මොකද වෙලාවක් තියෙනවා කියලා එක හදන්න ඉන්නේ බ්‍රේක් එකේදී තමයි මොකද නැත්තම් පොඩ්ඩක් නවත්තන්න නෑ ගෑඩි ඊයේත් මට ඔක වුණා මේ පොඩ්ඩක් ඒක හදන්න ඕන හරි බලන්න මේ then the second step is multiplying every term by 2. So if you multiply every term by 2, this will 2v square, 2vb square, 0.2 into v means vc square. It will be 1 with it. That's why I have multiplied it by 2 to eliminate vb. To eliminate vb. Right. Then I have taken this into this side. 2vb square into this side. Then 2 is a common factor. If you take 2 is out, what will have? If you take 2 is out, then you can say v squared minus vb squared. V squared minus vb squared. That means difference of squares. Difference of squares. So difference of squares means 2 into v minus vb into v plus vb. Is that clear? If it is clear, please raise the hand. Step. So v minus vb into v plus vb 2 times is equal vc square. Is equal vc square. Now you can subject vc from this equation. You can subject vc from this equation. If you take 2vb, to this side, if you take 2vb to this side, 2 times v minus vb, 2 times v minus vb is equal vc. Okay. So you have to apply vc squared here. Therefore, vc squared means 2 times means when you take the square, 2 will become 4. V minus vb will become v minus vb square. Is that clear? Step then 2 to 4 will be cancelled out. That is 2 puthe. That is 2 v minus vb will be cancelled out. 1 of V minus VB. Then answer is V plus VB. This one is 2 times V minus VB. 2 times V minus VB is 2V minus 2VB. 2V minus 2VB. Then you have to take this one here, then V, this one here, 3VB. Therefore, VB is equal V over 3. Is that clear? Calculation. If you got my calculation, please raise the hand. Everyone, I need your responses. Okay, thank you. That's only. Then you have to apply VB into this equation. If you apply VB into this equation, 2 over V3, 2 over V3, එක මේ පැත්තට ගන්න. හරිද? මෙතනට ගන්න. මේක තමයි ගොඩක් ලේසි. නැත්නම් මේකටත් අවුලක් නැහැ. VC is equal 2 times V minus VB. 2 times V minus VB. V minus VB කියලා කියන්නේ V minus V over 3. V minus V over 3 කියලා කියන්නේ 2 times V over 3. Therefore, answer is 4V over 3. Now that apply that. Harry. Okay. Now I will do these two questions when it is a MCQ. If you are given an MCQ question, if you are given an MCQ question like this, now I will teach you how to do this kind of MCQ without doing this much of calculation. Okay. Shall I erase? No responding. No problem, no? හරි බලමු පුතේ පළවෙනි එක. Okay. So you have to apply linear momentum conservation. ඒක apply කරන්න වෙනවා. Linear momentum conservation. So if you apply linear momentum conservation, if you apply linear momentum conservation, initially velocity is V පුතේ. All are V into all are V. Oh, sorry, masses all are 1. Masses all are 1. Therefore, if we apply linear momentum conservation, it is very clear. VA plus VB is equal V. This is due to linear momentum conservation. This is the final momentum with a VA plus VB. Initial momentum is V. I have not mentioned mass here because all the masses are 1 kg. Therefore, no need to write mass. Then, the other one is, the other relationship is what? Relative velocity of approaching is equal relative velocity of separation. Relative velocity of approaching ලංවීමේ සාපේක්ෂ ප්‍රවේගය. Relative velocity of approaching ලංවීමේ සාපේක්ෂ ප්‍රවේගය සමානයි වෙන්වීමේ සාපේක්ෂ ප්‍රවේගය. Relative velocity of separation. Relative velocity of separation. අපි දැන් මැත්ස් කරනකොට පුතේ මැත්ස් කරන කට්ටිය මෙතන මයිනස් එකක් දාලා කරන්න ඉඩ තියෙනවා. දැන් එතකොට මයිනස් එක නැත්නම් කියලා හිතන්න. ලග් වෙනවා. හරි. බලන්න. මැත්ස් කරන කට්ටිය මේක හිතන්න පුළුවන් මැත්ස් කරන කට්ටිය උතන මයිනස් එකක් දාලා කරනවා. දැන් එතනදී මයිනස් එකක් එන්නේ මෙන්න මේක නිසා relative velocity එක if you take relative velocity with respect to same object. If you take relative velocity with respect to same object, that means if you take relative velocity with respect to b, in both cases, you have to put minus mark. And you have to put minus mark, but it is easy to remember this thing. Relative velocity of approaching is relative velocity of separation, but when you take relative velocity, if you take relative velocity with respect to b first, when you take the relative velocity of separation, when you are taking relative velocity of separation, you have to take it with respect to it. මෙතනදී වා b වලට relatively ගත්තා නම් මෙතන a වලට relatively ගන්න. ඒ දෙක මාරු කරා නම් හරි. එතකොට මයිනස් එකක් ගැන හිතන්න ඕනේ නැහැ. හරි. මම මේක අදින්න තරකා. This is b. This is just before collision. Then this is just after collision. A, B, B. මේක දැන් ලියන්න ඕනේ නැහැ. හැබැයි මේක දැන් අපි ගන්න ඉතින් බලමු. Now relative velocity of approaching. If you consider the relative velocity with respect to b, now b is already stopped. It is already stopped. Therefore, relative velocity is equal to v into this side. V into this side. Now you have to take relative velocity of separation. Now initially you have to stop b with a. Now you have to stop a here. So if you stop a, you have to put VA to this side. Then the same thing should be done to this B with A. Therefore, relative velocity of B with respect to A is equal VB minus VA into this side, same side. Is that clear? Therefore, VA plus VB is equal V. VB minus VA is equal also V. This is 2. Therefore, if you add these two, if you add them, then 1 plus 2 is equal 2VB is equal to A. That means VB is equal V. So VA is equal to C. මානව හිතෙන් ගන්න පුළුවන්නේ. හිතෙන් ගන්න පුළුවන්නේ. ඒ නිසා මේ ඉක්වේෂන් එක ගන්න ඕන අපේ වැඩේ ඔක්කොම ටික ඔළුවෙම කරන්න පුළුවන්. ආයි කිසිම කතන්දරයක් ඕනේ. මේකත් කරන්න පුළුවන්. මේකත් කරන්න try කරන්න මේකත්. මෙන්න මේක ඉදා කරන්න. Relative velocity of approaching is equal relative velocity of separation. ඒ කියන්නේ මෙයා approach වෙනකොට relative velocity එක එතකොට ගන්න b ට relatively a ගන්න separate වෙනකොට a ට relatively b ගන්න. ඒක මාරු කරා නම් මයිනස් දාන්න ඕනේ නැහැ. අර හිතන විදිහ මාරු කරන්න විතරයි කරන්නේ. මේක තියන්නේ මේ පැත්තට නම් මේකත් ඒ පැත්තටම ගන්න. මේ දෙන ඩිරෙක්ෂන්ස් මාරු කරන්න එපා හැමතිස්සෙම මයිනස් දාන්න නේද? මේක තේරෙනවද දුස්සන්? If you got this one, please raise the hand. If you got this one, please raise the hand. අර මෙච්චර නලියන්න ඕනේ නැග්ගලා හදනවා. මේක දාගන්න පුතේ second method කියලා මේක දාගන්න. second method කියලා මේක දාගන්න. Then I can use this one. දැන් අපි මේකත් දාලා බලමු. So if I apply linear method of conservation, 2VB plus VC. 2VB plus VC. VC equal to, let me see. If I apply relative velocity method, relative velocity of relative velocity of approaching. If I apply relative velocity with respect to C, it is equal V. It is equal V. Now, relative velocity of C with respect to B means VC minus VB. VC minus VB. බලන්න. එක step එක. එක step එක. එක step එක. Therefore, if you multiply this one by 2 and add, if you multiply this one 2VC minus 2VB is equal to V. If we add them, VC is equal 4V over 3. 4V over 3. If you subtract these two, VB is equal, if you subtract these two, VB is equal here, V over 3. බලන්න නටන දෙයක් නැහැ. නටන දෙයක් නැහැ. බොහොම ලේසියෙන් ගන්න පුළුවන්. If you got this one, please raise that. If you got my calculation, please raise that. My calculation තේරුණා තුස්සන්න. I need resources for everyone. Hello, Shashmita. You have to remember, if you take the relative velocity with respect to one object, when they are approaching, you have to take the relative velocity of the other object with respect to first one when they are separating. පැත්තමාරුකානේ විතරයි තියෙන්නේ. හොඳටම තියන්න. මම ආයෙ කියනවා මේක එසේ වලට දාන්න බෑ. ඒක නෝට් ඩවුන් කරගන්න මේක එසේ වලට දාන්න බෑ දාන්න එපා. මොකද මේක අපිට ෆිසික්ස් වලට කියා දෙන තියරම් එකක් නෙවෙයි. ඒක දාන්න එපා. ඒසයි එහෙම බැරි ඉතින් අය ඒක දාන්න බැරි අරම ඒක තන්ත දාන්න එපා. මොකද මේ සිලබස් එකේ නැහැ ඉතින් සිලබස් එක දෙයක් කරන්න බෑ. ඈ මොකද දැන් උඹ මේ බයෝ කරපු ටීචර් කෙනෙක් බැලුවොත් බයෝ කරපු ටීචර් සමහරට මේක දන්නේ නැති වෙන්න දෙන්න. හරිද? ඒක නිසා මේ ඒක දාන්න එපා. ඈ හැබැයි MCQ ගන්නවා නම් මේක නොදා ඉන්න එපා. MCQ කරන්න මේක නොදා ඉන්න එපා. නැත්තම් එහෙම ඉතින් ඔයාලට ඒ ක්වෙස්චන් එක විතරයි කරන්න වෙන්නේ මුළු MCQ පේපර් එක. හරි? මොකද බෝල 5ක් 6ක් විතර තියලා නම්බර් මේ කොලිෂස් ගන්න හැවුවට පස්සේ ආයෙත් දුටෙන් මොනවා කරන්නද? ඔක දාන්න. අනිවාර්යෙන් දාන්න නෝ. ඊළඟට අර එක හිතන්න වෙනවා. ඒ කියන්නේ මෑස් සේම් නම් ඉතින් අනිවාර්යෙන් මේ මොනවද velocity එක exchange වෙනවා. ඒ අනම්මන කතන්දර ඔක්කොම හිතන්න වෙනවා. මෑස් සේම් නම් velocity exchange වෙනවා කියන කතන්දරය ගන්න වෙනවා. ඒවා අනිවාර්යෙන් ගන්න ඕනේ. Shall I erase? ඊළඟ මම පුංචි දෙයක් ඕගලන්ට කියන්න. මේක ඕගොල්ලෝ තනියෙන් කරන්න ඕන එක. මම කරන්න ඕන දෙයක් නේ තනියෙන් කරන්න ඕන දෙයක්. නිකන් මෙහෙම හිතන්න. හරිද? මෙන්න මේක අරගෙන ඕගොල්ලෝ රිලේෂන්ෂිප් එකක් හදාලා තියාගන්න පුළුවන්. MCQ කරනකොට මේක මාරු වටිනවද? නිකන් මෙහෙම හිතන්න. ඔබ්ජෙක්ට් දෙකක් තියෙනවා. Suppose there are two objects. Suppose there are two objects. The mass ratio of this object 1 to 2. That means if it is 1, this is 2m. Or otherwise, so if this is 2m, this one is 8. You can take both. So one is moving at v speed, other one is 0. Then what is the velocity ratio? What is the velocity ratio after collision? Then if it is 3 to 1, if it is 3 to 1, what would be the velocity ratio? What would be the velocity ratio? If it is 3 to 2, if it is 2 to 3, that's 2 to 3 ගන්න එපා. මෑස් එක වැඩි හැමනේ මේ පැත්තේ ගන්න. ඊට පස්සේ මාරු කරලත් බලන්න. මෑස් එක වැඩි එක මේ පැත්තට අරගෙන මාරු කරලත් බලන්න මොකද වෙන්නේ. මාරු කරලත් බලන්න මොකද වෙන්නේ. හරි. ඒක නිකන් ඉඳන් මම කරන්නේ. නිකන් ඉඳන් කරලා බලන්න. හැම වෙලේම මේ වගේ දේවල් කරන්නේ. මොකද වෙන්නේ කියලා. මෑස් එක වැඩි එක මේ පැත්තට ආවොත් අනිවාර්යයෙන් එක අවස්ථාවක් එන්න පුළුවන් මූ මේ පැත්තට රීබවුන්ස් වෙනවා. තේරෙන්න පුළුවන්. හරි. එහෙම වුත් එහෙම අනිවාර්යෙන් අනිත් පැත්තට ගිහිල්ලා කොලිෂන්ස් තව කීපයක් කරනවා. හරි. So there's a question in 2019 paper today. That question was added to your practice paper. I will discuss the thing. If you want to check that question, I don't have the. Okay, if we take practice paper, take your practice paper. Practice paper what? Third question. Third question of practice paper one. Third question of practice paper one. And now you can do that. Now you can do that and send me the answer. Now you can do that and send me the answer. There are 1, 2, 3, 4. 1, 2, 3, 4 spheres to take. That means there are a lot of collisions. Therefore, if you cannot apply these methods, you cannot do this question within 2 minutes. Sorry. Practice paper 1, 33rd question. 33rd question. That question was in 2019 paper. Okay. Then the next question would be, state what happens when capital M is 2 kg. 2 kg and find the final velocity of all the trolleys in terms of V. If it is 2 kg, then what will happen to the collisions? One. So if it is 2 kg, now A is here, A is at rest condition. Now B is moving into this side with the velocity. Now this mass is 1 kg. C. Now it has 2 kg. Now what will happen? to the collision of B and C. Now make VB කියලා දාන්න. මේක VC කියලා දාන්න. Okay. Remember, you have to apply linear momentum conservation and energy conservation law, but to do this quickly, I will use my second method, relative velocity method. Relative velocity method. Otherwise, this will be very huge calculation, therefore, but remember, when you are doing essay question, you have to follow that procedure. And මම මේක ටක් ගාලා ගන්න ඕන නිසා මම වැඩේ කරන්නම් මේක. හරි. බලන්න. If I apply linear momentum conservation into this side, here put a 1 kg, here 2 kg. Therefore, final momentum is equal VB plus 2 VC, that is final momentum. Initial momentum is V. Initial momentum is C. That is number 1. Then, if you consider about relative velocity of approaching is equal V පුතේ. මම ගත්ත එකට මෙයාට equal. ඒක මේ පැත්තට තියෙන්නේ. Then, relative velocity of separation. Relative velocity of separation means VC minus VB. VC minus VB. VC minus VB into this side. VC minus VB. This is 2. So if I add them, VB cancel out. Therefore, 3VC is equal to V putih. Therefore, VC is equal to V over 3. And that is into right hand direction because it is positive. Then, if I apply VC here, what will happen? 4VC, you know. 4VC. It will become 4VC. Therefore, from 1, now it is very interesting. From 1, it is very clear. If we apply VC here, it will become 4VC. Therefore, VB plus 4VC over 3 is equal to V. Then you have to take this into that side. Then it will become minus V over 3. Therefore, VB is equal minus V over 3. Minus V over 3 means you have to revert or you have to reverse the direction. Therefore, VB is equal V over 3 into this side. V over 3 into this side. Then what will happen? බලන්න එක ඉතින් ඉන්ටර් මාර ලස්සන එක ක්වෙස්චන් එක. හැබැයි ඉතින් මේක නේද හදනවා කියන්නේ සංසාරේ පා වෙනවා නේද? මේක නේද හදනවා කියන්නේ සංසාරේ පා වෙනවා. ඇත්ත කතාවද? මේ වගේම ක්වෙස්චන් එකක් තමයි 2019 වල තියෙන්නේ. මෙතන මේ ඔබ්ජෙක්ට් මේ තුනයි තියෙන්නේ. නැත්නම් ඔබ්ජෙක්ට් හතරක් තියෙනවා. ඔබ්ජෙක්ට් හතරක් තියෙනවා MCQ ක්වෙස්චන් එක. මේක ඔබ්ජෙක්ට් තුනක් තියෙන essay ක්වෙස්චන් එක. බලන්නකො තියෙන කතන්දර. හරි? ඉතින් මේක නැත්තම් ජීවිතේ හදන්න අමාරුයි වගේ නේද? But look at this one. Now VB is V over 3 into this side. Now it is very clear, Puthe. VB moves at this at this much of speed into A. And you know these two are equal in masses. These two are equal in masses. Like, you know. Now, look at this one. VC, here A is at rest condition. Now B is moving with the speed of V over 3. Now B is moving with a speed of v over 3 into a putih, you know both are having same mass putih, same equal masses, equal masses. Therefore, once they collide each other, B will become 0 and A will move at the same speed. Then, after the collision, then VB becomes 0, VA is equal to your 3 in this side. Is that clear? තේරුණාද? එතකොට VC යනවා පුතේ මේ පැත්තට 2VO3 ස්පීඩ් එකේ මේ පැත්තට යනවා. VB මොකද වෙන්නේ? B is at rest condition and VA moving into VO3 into other side. Is that clear? ඒක තේරුණාද උස්සන්න? මම මේ කරේ MCQ එකක් කරන විදියට. Is that clear? If it is clear, please raise the hand. And මේ විදිහට යහදුන්නේ නැත්නම් ඔයගොල්ලෝ MCQ කරන්නේ නැහැ ගයි. Therefore, finally, we see, C is moving 2V over 3 at a 2V over 3 speed into right hand side, and B is at rest condition. A is moving into left hand side at a speed of V over 3. So this is the final figure. If you got that done, please raise the hand. ඔය වගේ questions කරන්න තියෙන shortest method තමයි මේවා. ඒක නිසා මේවා අනිවාර්යෙන් ඔළුවේ තියෙන්න ඕනේ. නැත්නම් ඔය වගේ අර MCQ question එකක් ආවොත් එහෙම ගොඩාක් වෙලා යන විතරයි හදන්නේ. දැන් එහෙනම් මේක ලියා ගන්නකොට method 2 කියලා දාලා ලියා ගන්න. method 2 කියලා දාලා ලියා ගන්න. එහෙම නැතුව ලියා ගන්න එපා. Okay. Then the question number 4, if the tracks are fictional, would the static law you would use, would the static laws you use still be valid? Explain your answers. Yeah, they are valid Puteh, because in all cases, in all cases, one object collides with another object which is at rest. Puteh. Initially A collides with stationary B. Then B collides with stationary C. Therefore, after that, after this condition, again B moves in other side and collides with stationary object A. Therefore, in every collision, one object collides with another object which is at stationary condition. As that object is at stationary condition, then there's no, we can assume there's no friction force at the moment of collision. හරි. ඒ කොලිඩ් වෙන මොහොතේ අපිට ඒක නිග්ලෙක්ට් කරන්න පුළුවන්. අත්ත කතන්දරේ විතර මේ ප්‍රශ්නයක් තියෙනවා. අත්ත කතන්දරේ ප්‍රශ්නයක් තියෙනවා. නමුත් අපිට අවශ්‍ය නම් යොදන්න පුළුවන්. හරි. මොකද එක කොලිෂන් එකකින් එකක ෆෝස් එක දෙන්නේ නැහැ. හැබැයි මෙහෙම සෝරි ඒක යොදන්න බැරි වෙන්නේ. සෝරි බෑ බෑ මම පොඩක් කරලා දුන්නා. එතන අපිට යොදන්න බෑ පුතේ. මොකද මේක හිටියන මූ යනවනේ. මේක මට අවුතුනා නේ. මම අර කලින් එකේ කලින් ගන්න ඔලු තිබ්බේ මේ මොකක්ද එක ඔබ්ජෙක්ට් එකක් ගියා වුණාට එක ඔබ්ජෙක්ට් එකක් ස්ටේෂනරි කන්ඩිෂන් එකේ තිබ්බ වුණාට අනිත් එක යනවනේ. අනිත් එක යනකොට එයාට ෆෝස් එකක් එනවා. එයාගේ ෆෝස් එක ෆ්‍රික්ෂන් ෆෝස් එකක් තියෙනවනේ. එතකොට අපිට ඔබ දාන්න බෑ. ෆ්‍රික්ෂන් තිබ්බොත් දාන්න බෑ. අපිට කලින් ගානේ දුන්නේ පුතේ කලින් ගණන් දෙකේදී මොකද උනේ පළවෙනි මේ කියන්නේ එක ඔබ්ජෙක්ට් එකක් ඇවිල්ලා උඩ ඉඳන් වැදුනේ. එයා සර්ෆස් එකත් එක්ක කන්ටැක්ට් උන්නේ නැහැ. සර්ෆස් එකේ කන්ටැක්ට් එකක් තිබ්බේ වෙනත් ඔබ්ජෙක්ට් එකකට. එතකොට ඒ ඔබ්ජෙක්ට් එක ස්ටේෂනරි කන්ඩිෂන් එකේ හිටියනම් හරි ප්‍රශ්නයක් නැහැ දාන්න පුළුවන්. හරිද? මොකද අර මූව් වෙන ඔබ්ජෙක්ට් එක මූලේ මේ පුතේ මේ ට්‍රැක් එක නෙමෙයි. එයා උඩින් ඇවිල්ලා වැදුනේ. එයා උඩින් ඇවිල්ලා වැදුනේ නිසා ට්‍රැක් එක නෙමෙයි මූනේ. එතකොට එයාට ෆ්‍රික්ෂන් එකක් ඇප්ලයි වුන්නේ නැහැ. හැබැයි then what will happen? Now this moving object also in the frictional surface. Now this moving object also in a frictional surface, therefore its velocity continuously change with time. Therefore its momentum continuously change with time. Therefore, although this object is at rest condition, as this object is moving, there is a friction force exerted on this object. Is that clear? පැහැදිලිද? තේරෙනවද? If it is clear, please raise the hand. Sorry. Okay, write down this. Write down this thing. Although one object is in stationary condition, although one object is in stationary condition, although one object is in stationary condition, there will be a frictional force exerted on the moving object. Exerted on the moving object. Therefore, its momentum continuously changes with time. Continuously changes with time. Therefore, its momentum continuously changes with time. So, we cannot assume the momentum of the system is a constant. The momentum of the system is a constant. Is that clear? Is that clear? If it is clear, please raise the hand. If it is clear, please raise the hand. I need response from everyone. Haridu, Sasindu, Sashmidu. Okay. Okay, Bhudev. Today we have done 3 essay questions. Today we have done 3 essay questions. One is 21. Other one is 1989 question, 26. The next one is 34, 1993 questions. Therefore, today we have done 3 essay past paper questions. Today, past paper questions. Therefore, we have discussed a lot of short methods during these calculations. So, you have to go through those explanations again and try to apply them into another question. That's why I asked you to do some that means some extra questions. Extra questions means sometimes you can assume there is 2m and 1m with v velocity and 2v velocity. So likewise, you can change the masses. You can change the masses and take the final value of the velocities. So like as you have to train to apply that theorem. Okay, otherwise you won't be remembered, especially bio students, because math students can have this kind of questions in maths. But the thing is, you have to train as well. Okay, paper class. Then I will share you the link of theory class. Okay, now it is 7:15. 7:45 we can start the theory class. Sorry, 7, not 7, 5. 17, 5:45. 5:45 we can start the theory class. Okay, I will share the link for theory class separately. Okay, so I will end this session. Everyone. You can take a break.